Good evening, Yuvraj sir. I hope I'm audible. So, shall I start, sir? Do I need to wait? Okay, sir. Good evening, everyone.
Good evening, ma'am.
Good evening, Kavita ma'am. So, shall I start the session? Everyone is ready? Yes. Shall I start? Are you all ready?
Yes, ma'am.
Okay. So, I think meanwhile, if few more people are joining the session, I'll conclude till the date whatever I have discussed so far, right? So I think I have started with the basics of SPSS. There I have talked about the environment of SPSS, right? I think initially I talked about the things like basics of research, right? There I have talked what are the components of research. We have seen so many components. We have understood. I tried to explain the importance of literature review. We have seen how to develop hypothesis, what are the variables, what are the measurement scales, and then we have seen SPSS environment. And there I talked about there are two views, the data view and the variable view, and we have seen the working of both the views. And then further, we have seen how to define variable, what are the certain rules which we need to keep in our mind while defining the variable. And we have also seen various parameters which can help us to define a particular variable in SPSS, right? So this is what we discussed till now. On day 1. Then I think I discussed the reliability and normality on the day 2. There I talked about the importance. Firstly, when you need to check the normality, and then we have seen when we can check the reliability. We have seen the definitions and all. We have seen the methods, and we have seen ways of checking the normality also. Then I have discussed the chi-square test, and then we have seen both the categories of the chi-square test: goodness of fit and independence of attributes. And we have seen how we can apply these two using the SPSS. Also, we have seen the interpretation part, right? This is what we have we have done so far. Today, I will start with the next concept, which is the parametric test and statistics, right? So I think sufficient number of you have joined the session. So now I'm starting with the session. Give me a second. I'm just sharing my screen with all of you. Yes, I shared my screen and I'm showing you the slides. I hope the slides are visible to everyone.
Yes, ma'am.
Yes, ma'am, visible.
Yeah. So, as the agenda is the one sample t-test for the day. Firstly, we need to understand the term parametric test, right, which I have already discussed with all of you. But once again, I'm trying to make you understand the term parametric test. Generally, when we talk about hypothesis testing, so we are talking about the inferential statistics. There are two types of statistics: descriptive and inferential. Descriptive, I think, the way of understanding our data using the descriptive statistics or its various methods, we can summarize the data, right? And we can understanding about the data using the descriptive statistics. When we talk about the inferential statistics, we are trying to conclude about the population parameters using the sample statistics. Or I can say whatever I will conclude for the population, that I'll do using the sample, that is known as the the inferential statistics, right? So here there is a concept of population and the sample. Population is generally a sufficient large number or group of people which are pertaining to my research problem, right? if I want to study the, I think yesterday or day before yesterday, maybe I have taken one example. We want to see the perception or the satisfaction level of the students using various methods of study or methods of teaching, maybe. So from which teaching method they are feeling or satisfied. So this type of satisfaction, suppose I want to measure, right? So in that case, all the students, those who are means all the what I can say children, those who are studying can be considered here, right? But I need to be specific that whether I want to conduct this study for the school level students or for the college level students. Then I need to also clarify this thing that what will be the age group for that I am going to conduct this study. So likewise, so that way then I'll decide this will be my population. I need to decide what will be my reason in that case. And then if still we are finding that the sample size, the population size is very large, that means we cannot access each and every unit of the population. In that case, what we do, we are trying to draw a sample from the population, and we are generally whatever sample we are drawing, we are generally what I can say considering this thing that the sample is also having the same properties whatever the population is having. So for the purpose, you need to what I need to say that you need to check certain assumptions. So in statistics, I think previously also I said there are certain assumptions for almost each of the statistical tests, right? So that way, here when we talk about the one sample t-test, so I'll start the session with the t-test now. That t-test generally it is also known as the student's t-test, right? This test is also known as the student's t-test. I think let's start it. So this test is also known as the student t-test. Apart from that, when we say t-test meaning is very simple. Whenever we want to find the difference in the two categories, in that case we are using the t-test, right? So purpose of t-test is to find the significant mean difference in the two categories, right? But when we are saying one sample t-test, so one sample t-test, as I said, it's a parametric test because it is based on the parameters of the population. So in that case, as name is itself saying one sample, that means I am having only one sample. So from which sample I will compare my that particular sample. So here what we are trying to compare the population mean and sample mean. Means we will be having a sample, we will calculate its mean, and we will compare that mean with the population mean, because mean is one of the parameters of population. So I want to see this thing whether the sample mean or population mean is similar or not. Means whether the sample is belonging to the same population which is having the same mean, right? So this way, this is the concept behind the t-test. Is it, I think, maybe a little logical for you? So when I'm saying, I think first point is very simple. It's a parametric test. Second point is the one sample t-test determines whether the sample mean is statistically different from known or hypothesized population mean. Means, as I said, you need to compare sample mean with the population mean. So sample mean, it is very obvious we will be having, because we are having the samples. So using that data, we can collect the mean of the sample. But when we talk about the population mean, in that case, either it should be known to us or you need to assume it, right? So you need to decide upon if this particular sample you are picking, whatever from whatever population it is coming, you need to decide that this will be approximate mean of the population. So that means there are two things in case of population mean. It should be either known to you or you need to assume the population mean value, right? Then the variable used in the test is known as test variable. So whatever variable I want to test here, that variable is generally known in SPSS, that variable is known as test variable, right? So we are comparing the test variable against the test value, and this test value will be the value of your population mean, right? So one more thing in case of the t-test, I think many a times we are generally saying this thing, population size is less than 30. Apart from that, there is one more condition. The condition is that if you are not having the idea about the standardization of the population, In that case, also we are going for the we are going for the t-test. So for t-test, the mandatory condition is you if you are not knowing the standard deviation of the population, in that case you can apply t-test, or else there is a z-test. So the difference in z-test and t-test is, main difference is that the population standard deviation is known for the z-test and unknown for the t-test, right? So I think it is very relevant when we talk about the present day situation, or maybe when we talk about the real situation or real world situation, because we are conducting this study on the real data or on the real world population, and when the population size is very large, so I think it is very difficult for us to know the standard deviation of the population. So that is why you need to assume this thing, that the standard deviation of population is unknown. That is why we are applying the t-test, right? I hope I'm clear on the slide 1.
Yes, ma'am.
Yeah. Now, procedure of testing the one sample t-test. So in statistics or statistical books, you can find there are certain steps generally when we teach to the students. So we are generally saying, asking them to formulate the null and the alternative hypothesis. So I think null hypothesis is in itself is very clear. Null means what? Something like that which is not existing. We are calling it as null. So many times we are generally formulating the null hypothesis as there is no significant difference. So we are saying this thing that the difference is not existing, right? So this becomes our null hypothesis. And alternatively, we are saying that there is a significant difference, right? Then after that, you need to set the value of alpha. Alpha value means the level of significance. So you need to set this. Usually it can be the 1%, 5%, or 10%. In social science research, generally these are the 3 known percentages which you can set. But if you are keeping the alpha value very high, that means your results are not reliable results. So you need to decide upon what will be your alpha value is, right? Mostly the 5% is generally used by the researchers in the field of social science. But from the field to field, this alpha can change. So you need to decide upon in which field you are working. So how much risk you can take. So that risk you need to decide, and that way you can set your alpha value. Next one is the calculate. We need to calculate the degrees of freedom. So degrees of freedom is nothing, but it is the number of observations minus 1. So that is how many of the observations are free to take their values, right? So this is known as degrees of freedom. Then you need to state the decision rule. Decision rule meaning is you will priorly decide this thing if your calculated value is less than your tabulated value, or your p-value is less than your level of significance, something like that. So whatever is a thumb rule that you need to state. And then you need to calculate the value of t using the formula, which is generally x bar minus mu 0 divided by s divided by root n. This formula generally we are using when we are calculating the t manually. And then we need to state the results. So state the results will be depending upon whatever value you are getting here from this particular formula, and then you need to compare that whatever decision rule you have set prior, and then you will conclude your results. So this way, this is the manual process of applying one sample t-test. Further, when we talk about the comparison manually, generally we compare the table value and the calculated t-value. So for the table value, you can find generally in the using the e-resources, you can download such kind of tables. These are nowadays very easily available. So you can find this is a t table. There are varieties of t table available. So according to your need, you can find them, right? You can see here it is written the 2 tail or 1 tail, right? So these are the level of significance mentioned at the very upper side, right? At the extreme left, you can find the degrees of freedoms are mentioned here, right? Fine, everyone. Then, in context to the degrees of freedom and the level of significance, you can locate your calculated value. So that way, you will get the value of t from the table, right? Then further, if you can look at the degrees of freedom, you can find here you can find here that after 1000 you are looking the last row is showing the Z value. So as if you can recall, I have said this thing. Generally, when we are increasing the size of the sample, so your data is tending towards to the normality, and that way generally rather than applying the t-test, you can also means your t is generally becoming the z-test. So that is why there is no difference in these two when the data size is sufficiently large for us. So that way, this is the one thing. Moving to the next. Now, how you can formulate your hypothesis. So this is the symbolical way of uh, showing the hypothesis of your test. The first one is saying mu is equal to x bar. Mu is known as your population mean. X bar is your sample mean. Means we are comparing population and sample mean. So we are saying mu is equal to x bar. Alternatively, I am saying mu is not equal to x bar. That means it can be either greater than or it is maybe less than, but I am not sure. So that is why I have written mu is not equals to x bar. So whenever you are saying, looking at your alternative hypothesis, whenever you are saying sample mean is not equals to the population mean, that means we are saying this thing that this type of test is known as two-tailed test, right? That means it is showing not equals to, meaning is very simple. It can be either greater than or it can be either less than, but I have not mentioned it clearly. So that is why it can be fall on either of the tail, right? So that way two tails are involved here. Second one is mu is greater than n equals to x bar. That means population mean is greater than or equals to the sample mean. Alternatively, the sample mean is greater than to the population mean. So when I'm clearly stating whether the sample mean or whether the population mean is greater than or equal to, that way it is known as the one-tailed test, right? So in the third position also we can find when I'm saying that population mean is less than or equals to sample mean. Alternatively, I'm saying that population mean is greater than the sample mean. So we can say that there is only one tail involved, right? I hope it is clear. Any doubt?
Yes, ma'am.
Okay. So you can see when I'm saying the two-tail test, the first serial number I'm talking about. So in that case, when I'm saying two-tail test, so that means your rejection reason, the red area you can see here, this is indicating this is your rejection reason of your null hypothesis, and rest of the white reason is
Ma'am,
the,
your slides are not changing.
is it?
Hello.
Everyone,
now
are you
it is
able to see? Hello? Slides are visible, I hope.
Yes, ma'am. Now it is visible.
Fine. So I think I said this thing that the red area is indicating that the this will be your rejection reason for the null hypothesis, and rest of the area, that is the white area of this curve, is known as the acceptance reason of your null hypothesis. This is the case of the two-tailed test. So on both the tails, the rejection value will fall. In the case of one-tailed test, you are clearly looking at here. So this is the rejection reason. That means your rejection value will fall in this region, and rest of the region is known as the acceptance region of the null hypothesis. Likewise, in the case of right-tailed test meaning is mu is greater than sample mean. Mu is greater than or equals to your sample mean. So this is the case of right-tailed test. So that means the rest of the reason will be your acceptance reason of the null hypothesis, and this red reason is indicating this is the rejection reason, right? So one tail, two tail meaning is, I hope, clear now. Is it fine?
But when we will use one-tail test and when we will use two-tail test?
I think it will be totally depending upon the researcher. You need to decide upon if you are clear that you are assuming this thing that the population mean will be the greater than or the sample mean. So that way you can formulate your hypothesis, or you can formulate the hypothesis for the two-tailed test, and looking at your results, you can finally conclude that whether your sample mean is greater than the population mean or not. Right? Fine.
Yes.
So
Yes,
now,
ma'am.
yeah, thank you, ma'am. So now you can see, I think this was previously I have shown you the way of formulating the null hypothesis in the form of symbols, null and alternative. Now, how you can formulate the one sample t-test hypothesis in the word form. So there you can find there is no significant difference in the sample mean and the population mean. This is your null hypothesis. This is for the two-tailed test. When I am saying there is no significant difference, right? If you are stating that the sample mean is significantly less than or equal to your population mean, this is the one-tailed test hypothesis. Or if you can say sample mean is significantly more than or equal to population mean, this is also the case of the one-tailed test, right? So this way you can formulate your null hypothesis, even your alternative hypothesis in the word form also, in the text form also. Talking about the assumptions of one sample t-test. So the very first assumption says the dependent variable must be continuous. So in case of one sample t-test, you will be only having a single variable. That variable we can take as a dependent variable, and this variable should be numeric in nature, or you can say this variable should be continuous in nature. That means this variable should be measured on either interval scale or on ratio scale. Second one says the observations are independent of one another, right? Meaning is very simple. If you will collect an observation from a particular person only once, that way you would be able to maintain this particular assumption. So first two assumptions of the t-test you can only complete, or you can check by observing the data of your whatever data you have collected. So if you will look at that data, if you will be very careful by collecting the data, so that way you can ascertain these two assumptions of the one sample t-test. The remaining assumption says the dependent variable should be approximately normally distributed. Whatever is your dependent variable, it should be normally distributed, right? So I think we have discussed various methods. Using those methods, you can decide upon in which method you are comfortable. That way you can apply those methods to test or to check the normality of your dependent variable. The last one says the dependent variable should not contain any outliers. So that means there should be no outliers available in your dependent variable. So meaning is very simple. That means you can use the box plot for checking this. And I think you people are knowing outliers are nothing but these are the very distinct values which are not almost similar to your rest of the data points or values of your data. So that will be known as the outlier, which is very, very different, not matching with the rest of the other observations or the data points of your data. So it is known as the outliers. Till here, I think I'm clear. Any doubt?
Yes.
Okay. Okay. Now, I think we have seen previously also there is a method known as the histogram. Using the histogram also we can ascertain the normality of the data. But I think we know histogram is nothing but these are the bars should be symmetrical at both the sides. Means whatever is your biggest bar, it should be coming at the middle, and then at both the sides the size of the bar should be almost similar. That way you can call it as a normal distribution of the data. But if suppose you can find here there is the proportion of the bars are not same even, so in that case also, if such kind of distribution is shown by the data in that case also, we can say that the data is approximately normally distributed, not exactly but approximately. Fine, everyone. May I proceed?
Yes.
Now, talking about box plots, so I think this is depending upon whatever is the range of your data. Accordingly, the box size will be varying, right? So this way you can find there are two box plots available here. I'm talking about the left side box, right? So there you can find the one outlier there is very coming very upper side. You can find this is the outlier where I'm rotating my mouse, right? You can find a circle here. So this is the significant outlier, right? But if the outliers are very near to the whisker, upper and lower, so they may be considered in your data. But if any of the data points is going very far from the whiskers, either side, in that case, you need to decide upon whether you are dropping that particular data point from your data or you want to keep it. So that will be the decision of all of the research. Coming at the next box plot, you can find here. Here also you can find usually the size of box is very good. So that way it is indicating that the data is maybe ranging or what I can say spreading in a good range. So that is why the box is size is very good here. But again you can find against or maybe beyond both the whisker, we are finding there are circles, right? So these are known as the outliers in the data. In SPSS, I think there are two ways of depicting the outliers. If you have seen when I have discussed the normality checking, there in the box plot, there were the small circles and also there were asterisks. So circles are like they are not significant outliers, but asterisks are the significant outliers, and that means these outliers may impact your results. So that will be the call of the researcher, whether the researcher want to drop them or not. Clear? May I proceed? Done? Yeah. Now you can see there are a few more methods I told you, that is QQ plot of checking the normality. This is one more graphical method. So you can find at the left upper side, if you can see where I'm showing you through my mouse, that this is the symmetric distribution. That means this is the perfect normal distribution. So that way, in that case, the QQ plot will be like this, right? When your data is positively skewed, I'm talking about the upper right side. Here you can see your data is positively skewed. In that case, you can find that the QQ plot will be like this, right? Then if I'm talking about the symmetric data with the fat tails meaning is that there are very various or so many data points which are falling on your tails, right? So in that case, the QQ plot will be like this one. Talking about the right side, lower right side, you can find this is your negatively skewed data. So in that case, you can see the curve will be like this, and that way you can say or comment that your data is negatively skewed, right? So this way you can ascertain normality looking at the various plots like the histogram, box plot, and the QQ plot. I hope these are clear. Any doubt?
No doubt.
Okay. Okay. So now this is the process. Using this process, we can check the or we can apply the one sample t-test, right? So I think this is about the theoretical aspect of the one sample t-test. Now we will go for the what? We will go for the SPSS and we will see how you can apply one sample t-test. So for the same, I have given you the sheet there in your WhatsApp group. I hope you have found it. The sheet name is, I think, one sample t-test, right? I hope everyone has downloaded that. Yes, downloading done.
Yes, ma'am. Yes.
So shall I start?
Yes, ma'am.
Fine. Meanwhile, I have also opened the file. Give me a second. I'm sharing my screen again. Visible, everyone?
Yes, ma'am. Yes.
I think I have shared the two sheets. Both the sheets are similar. Only in the latest sheet, I have added one more variable for you, which is the weight, right? So this is for your practice purpose. I will use only one variable, and then I'll wait and I'll ask you to perform the one sample test on the rest of the two variables, right? So firstly, you can find these are the IDs of the students. Then the score, whatever score whatever the score they have attained in any particular subject, these are listed here. This is their IQ level, and these are the weights of this, right? So all the three variables you can see listed here are the continuous, right? Are the numeric variable. I hope it is clear. Numeric variable is clear to everyone.
Yes, ma'am.
Right. So this way, I think first assumption we have checked here by understanding the nature of the variable. Second one is we need to see or talk about that there should be or observation should be independent to each other. So it is very clear if I will collect the score of one student only once. So that way I will able to maintain the second assumption of the one sample t-test. Now for rest of the assumptions, what you need to do, we will see here one by one. So can anyone tell me if I want to check the normality, because the next assumption is the normality assumption and the outlier. So I think both we can check simultaneously. What I need to do, anyone? Anyone? I think I discussed this thing in the second class when I was talking about the reliability and the normality. I hope you can recall this. Anyone? Or do I need to tell you?
The question. Didn't get the question, ma'am.
I said how to check the normality of the variable in SPSS. Anyone who can recall this?
Ma'am, through skewness, kurtosis,
Hmm.
through kurtosis and this.
Okay, fine. Okay, fine. We will do using that also, I think. So what you need to do, you will go in the analyze, right? You will go to the descriptive statistics. Fine. Fine, man.
Yes, ma'am. Yes.
Yes, ma'am.
Descriptive. So analyze descriptive statistics and select descriptive. So I think everyone is following me. Done.
Yes, ma'am. Yes.
Done. So now after that you need to click on the descriptive statistics like this. So the dialog box will appear. Here, suppose I am picking the first variable, which is score, and shifting this variable into this box. Fine. Fine.
Yeah, ma'am. Yes. Yeah.
Now click on the options button. There you can find mean, standard deviation, maximum and minimum value is checked. Right? We want to calculate the kurtosis and skewness as well. So you need to select the rest of the two boxes. Done.
Yes, ma'am.
After this, you need to press the continue button, and then you will be back on the previous box, and there you need to click on the OK button to get the output. I hope you can see the output here. Fine, everyone.
Yes, ma'am.
Looking at the value, you can find the mean is 68.53, skewness is minus 0.112, and kurtosis is minus 0.785, right? So can anyone help me to interpret these two? Using this, how can I comment on the normality of the score?
I guess the data is not normally distributed
Okay, why, ma'am?
because it is negatively. I guess it is a negative skewness.
Okay, fine. May I know the name who is interacting? Who is interacting?
आपने बोलो.
Sorry? Who is interacting? Ma'am, may I know the name?
Ma'am, myself Bhavna.
Bhavna, ma'am. Okay, fine. Fine. Bhavna, ma'am is very correct here, but again, I think we need to do checking of this using one more thing. Here, if I will look at the skewness, this is negative, but it should be 0 for the normal distribution. But I think I have mentioned this thing in the last session or last to last session that it is, I think, difficult in the real world to get a data in which skewness will be 0, right? So we need to compromise a little bit with this particular thing. So what we are taking? We are taking the threshold values of skewness and kurtosis both, and that way we will ascertain this thing that whether that particular value is falling in this or following that particular threshold or not, then we will comment on this. So here if you will talk about the threshold, so for skewness generally we are taking it as -2 to +2. For kurtosis we can take it as -3 to +3. So if I will talk about this range, you can find both the values are falling in that range. -2 to +2, this is in that range. -3 to +3, this is in that range. Right, it is clear?
Yes, ma'am.
Right. But one more thing you need to check, probably using that if I will check, so maybe it will be what? Normally distributed. So how you can do, you can go to the analyze, descriptive, statistics and explore. So I think that day we have done this checking using this option that is explore. So you need to select this, shift your variable in the dependent list box. Fine. I hope it is done. I hope everyone has located this option. Shall I?
Yes, ma'am.
Yeah. Now, once you will click on statistics, I think this is the by default option. At the 95% confidence interval of mean, you will go with the descriptive statistics. That means your level of significance is 5%, right? So click on the continue. Click on the plots button. Then here, I think I have told you we will go with the first option. And then deselect stem and leaf and we'll go with the histogram. And lastly, normality plots with tests. I think, right, everyone? Till here, I think I have already explained previously.
Yes, ma'am.
Now you can press continue button and then you will be back. Here you can click on OK to generate the output. I hope you have got the output like this. Done, everyone? Shall I start?
Yes, ma'am.
Yeah. So you can find once I will talk about the case processing summary, which is indicating you the missing value in the data. So your data points are 40. There is no missing value. So total is 40. Coming to the next table, which is about the descriptive statistics, you can find mean is 68.53. Mean score is 68.53. 95% confidence interval for mean. Lower bound is 63.23, upper bound is 73.82, right? So if you will look at these two, you can find meaning is very simple. That means if from the same population, you will pick another sample, so the mean score or the mean of the score will fall in this particular range. So it will be between 63.23 to 73.82. Is it okay?
Yes, ma'am.
Then Talking about the 5% trim mean, I already explained this. You need to trim the outliers. You need to trim the outliers, and that way you will calculate the mean value. This is known as 5% trimmed mean. So you are removing the outlier and then you are calculating the mean. So if you will compare these two, you can find there is a very minor difference is coming, right? Looking at the median value, which is 68, then the variance is 273.846. The standard deviation is 16.548. Minimum of the score is 35. Maximum is 100. Range is 65, which is the difference of maximum and minimum. Interquartile range is 25, which is the difference of third quartile and the first quartile. Skewness is minus 0.112 and the kurtosis is minus 0.785. Then one more table is coming here, which is the table of the Kolmogorov-Smirnov and the Shapiro-Wilks test, right? So you can find usually when the sample size is small, we will report Shapiro-Wilks test, right? So you can see the statistic, Shapiro-Wilks statistic is 0.980 for the 40 degrees of freedom. The significant value is coming as 0.696. So can anyone recall and tell me what was the hypothesis I have told you for the this normality test using the Kolmogorov and this Kolmogorov-Smirnov and the Shapiro-Wilks test? Can anyone tell me? Everyone, it is means I am expecting an answer. Can anyone tell me the hypothesis? Yes. Yes, I am waiting. Anyone? Anyone? No answers? Yes.
Not able to recall, ma'am. We're really sorry.
Okay. So the hypothesis which I told you for the normality test is variable is normally distributed. This is your null hypothesis, right? Now looking at the significant value, which is 0.696. So what will be my conclusion? If p value is 0.696, yes,
Null hypothesis will be rejected, I think so.
null hypothesis
Is rejected.
rejected. Okay. Anyone else? Okay. Anyone else? It is correct. Anyone?
Less than 0.05, na?
It is greater than, ma'am. You can compare. I think, sir, I don't know who was talking. So it is 0.696. And we are saying 0.05, that is 5%. So it is greater than or less than? It is greater than or less than?
It is greater than.
It is greater than. So if the p value is greater than the level of significance, what will be the decision?
Rejected.
We are going to accept the null hypothesis.
Accept.
Right? So if we are accepting the null hypothesis, that means what we are concluding? Variable is normally distributed. Right? Is it clear?
Yes, ma'am.
Yes. Looking at the histogram, you can find histogram. I think looking at the histogram, it is very difficult to comment anything because maybe the data is very less. It is only 40 observations, so that is why the histogram size is or the bars are not properly coming right? But still, if you want to keep a bell-shaped curve on this, you can double click on this. In this, you can find the lower bar. There you can find the second last option is the distribution curve. There you need to click, and then you can find it is by default normal. So you can close this, and then you can close your chart editor as well. Will be on the output where now you can find at the output where also the bell-shaped curve is coming. So that means it is showing you that your data is approximately normally distributed, right? Is it clear?
Yes, ma'am.
Now looking at the QQ plot, if I will look at the QQ plot, although all the data points are not exactly following the fitted line, but somewhere you can say the data points are very close to the fitted line. So that means according to the QQ plot also we can comment that the data is approximately normally distributed, right? Going down, this graph you do not need to report or discuss. You need to only talk about now the box plot, which is the last graph here. So this box plot is indicating you the normality also, and also it is talking. This is also talking about the outlier, right? So you can see either if I talk about this upper whisker or either I talk about this lower whisker. At both the side, if I will see, there is no outlier available. That means there is no outlier in the score variable. It is clear?
Yes, ma'am.
So that means we have seen all the assumptions and we have came to this particular conclusion that all the assumptions are met by our data. That means now we can apply the one sample t-test, right? So we will go to the analyze now to apply the one sample t-test. So I'm expecting everyone to go to this and then select the compare means, and then you can find one sample t-test is available, right? Is it fine?
Yes, ma'am.
You will click on this, a dialog box will appear like this. It is okay.
Yes, ma'am.
Now you can shift your variable which you want to test into the test variables box. Done.
Yes, ma'am.
Now, if you have shifted this to this particular box, that is the test variable box. So this is your test variable. You want to test this variable using the test value, which is there at the end. So in this box, you need to enter the test value. So test value, if you can recall, I said this will be the known or this will be the hypothesis. So if it is not known to you, you can assume this value. So maybe suppose this is the scores. These all are the scores of my class only. So maybe what I can say this thing, that suppose from the past experience, whatever the data I am having, I can say this thing that generally the mean score in my class is suppose 65, right? So I will pass here 65. This will be on the basis of your experience, or you need to take a guess on the population mean. So suppose I'm assuming that the mean score in my class is generally 65. So I have kept this as a 65. It is okay.
Yes, ma'am.
Now, although you do not need to do anything, but still you can click on the options button. It is showing you the confidence interval percentage, which is 95. That means this is a by default percent. If you want to make any changes, suppose you want to test your hypothesis at 90% or maybe 99%, that also you can set. So if 95% is the confidence interval, that means 5% will be the level of significance. Similarly, if the confidence interval is 90%, that means your level of significance will be how much?
5%.
No, if
10%.
confidence interval is 90%, then
10%.
10%.
10%.
Very correct, very correct. similarly, if confidence interval is 99%, then the level of significance will be
1%.
1%.
Right. Very correct. Very good, everyone. So this way, you need to decide firstly. SPSS, as I said yesterday also, it works on the by default 95% or the 5% level of significance, right? So if you want to make changes, you can use your keyboard and that way you can set that value. But I think being a social science site, I am generally using 95% only. So I am pressing the continue button here. And then I need to only press the OK to generate the output. So I think I can press OK. Everyone, it is fine. May I press OK?
Yes, ma'am.
Yeah. So once you are pressing OK, you can find at the output where you are able to see the output. Now, looking at the first table, you can find we are having total 40 observations and the mean is 68.53. This is the mean score. Standard deviation of the score is 16.548 and the standard error of the mean is 2.617. Coming down, this table will give you the t-value of the data, right? So that way you can find this is the t, which is 1.347. For the degrees of freedom, 39, this is 40 minus 1, right? Then talking about the significant value, which is 0.186. So can anyone tell me if the significant value, that is p value, is 0.186, what conclusion I can draw?
I guess we'll reject the null hypothesis.
Okay, 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 everyone, it is fine?
Yes, ma'am.
Okay. No, we are going to accept the null hypothesis. I think you need to make a note on your notepads or whatever, wherever you are noting down these notes. I'm expecting you please note this. If p value is less than level of significance, in that case, you need to reject the null hypothesis. Give me a second. I'm coming there in a chat. I'll write this. So I'm expecting you to please note down this or copy and paste. If p is less than level of significance, reject the null hypothesis. Or when p is greater than 0.0 or level of significance, accept the null hypothesis. I think I have sent there in a chat. I hope you have found it.
Yes, ma'am.
I'm expecting you at least copy and paste somewhere. This will help you. And then gradually, once you're using it very regularly, this will become your habit, right? Fine, everyone?
Yes, ma'am.
Yes. So now you can see I am back. So that way you can see the p-value is greater than our level of significance, which is 0.05. 5% meaning is 0.05. So 0.186 is greater than 0.05. So that is why we need to accept the null hypothesis, right? Is it fine?
Ma'am, please repeat.
I think I already written there in a chat, ma'am. Similar thing I said. If p-value is greater than your level of significance, that means p-value is 0.186. Level of significance was, I think we already discussed, it is 5%, that is 0.05. So p, that is 0.186, is greater than 0.05. So we need to accept the null hypothesis, right?
Yes, ma'am.
So what will be the hypothesis here? Can anyone tell me? I think we have not formulated the hypothesis. What will be the hypothesis here?
The population mean and the scores of the class is I'm sorry because I'm not getting the other.
No problem. At least you attempted. Good. Take your time, decide, then tell anyone. Meanwhile, anyone else can take a lead and can communicate me this thing, how to formulate the hypothesis. There is no difference between the class score and the average score, I guess, that generally students take.
Okay. Okay, fine.
Because that was related to the difference between population mean and sample mean. So I'm just trying it.
Okay. Okay. Anyone else? Okay, okay. No problem. I'm telling you, there is no significant difference in the population mean score and the sample mean score. Very simple. Right? Very correct, ma'am, right? So I am going to accept this hypothesis. That means I am saying there is no significant score in the population mean score and the sample mean score. That means both are almost similar. It is clear?
Yes, ma'am.
Right. Means that difference is there, but it is not significant. Means it is not significant. So I mean I do not need to pay attention on this, or I do not need to take any action on that. So this is the meaning of this, right? Now it is fine.
Madam, excuse
Yes,
me, I have it.
Yeah.
Madam, here T value, T score we got 1.347.
Hmm.
And we are comparing with the level of significance, and we are seeing the value of T. Then what is the use of T value? Then when to
What is
apply?
the?
When to use?
I'm not getting. What is the?
Madam, we are comparing with P value with level of significance.
Yes.
What is the use of T value? Calculated value this. When to use?
So on the basis of the T value only we can calculate the P value. Right? Although we are not using your formula, but the P value is only derived from the T value. Right? So if you want to consider the T value, in that case you need to have the table value. So I think I've shown you. You can download the table, and using the table value, you need to have your degrees of freedom. You need to have your level of significance, and that way you will get the table value. And then you can compare table value and the calculated value. That is also fine. So that way these are the certain rules of taking a decision of rejection or acceptance of the hypothesis. Either you can go for the p value and t value concept, or you can go on the calculated in the tabulated value concept, table value concept, or second you can go for the p value concept. In both the cases, results will same. They will not differ, because as I said, p value is also coming from the t value. Is it fine, sir?
Yes, madam. And another thing, madam. Here our test is showing here 2 till test. That means the value is showing 0.186. This 0.186 is divided by 2 value or one side value?
It is the two side. It is 2 till test, because your rejection value will fall on both the tails. Meaning is that.
That means left side is 0.186 and right side also 0.186.
Half of this. 0.93,
Yeah, that's what
0.93. Yeah.
Yeah. Exactly.
0.093, 0.093. Fine.
Thank you.
Yeah. Now, I want to show you one more thing. Suppose we will go again to the analyze. Now, I'm selecting again the compare means and selecting the one sample t-test. This time I'm assuming, suppose the population mean, that is my test value, is 60. That is the mu. Is it fine?
Yes, ma'am.
I'm pressing OK. Now you can find, I think first is, this will not change because we have not made any changes in the data, right? We will come here at the next table, which is the T table. Here you can find. Now your T value is 3.258, because the formula I have shown you, if you can recall. Give me a second, I'll show you again. This, you can find it is x bar minus mu. So if mu is changing, that means your numerator is changing. Previously it was 65, now it is 60. So numerator is bigger now. So that is why your T value is different from the previous T. right? And in that case, you can find the p-value is 0.002. And if it is 0.002, what conclusion we will draw?
We will reject the null hypothesis. There is difference between.
Very good. Very correct. Means we are going to reject the null hypothesis and we can conclude there is a significant difference in the population mean score and the sample mean score. Right now the question comes, I think one of you have asked me when to make that two-tailed test hypothesis and when to make one-tailed hypothesis. So I told you always make usually the two-tailed hypothesis, and then looking at your results you can decide upon this. So now if you will look at your result, as your result is saying there is a significant difference, means difference is existing between the population mean and the sample mean, right? And that way you can find the mean difference is coming positive, which is 8.525. That means your sample mean is greater than to your population mean, because population mean was 16 and the sample mean is 68.53. So we can conclude this thing that the sample mean is greater than population. So if your null hypothesis is rejected of the two-tailed test, that way you can decide or declare this thing that which thing is different from which thing is greater than and this thing is less than. It is clear?
Yes, ma'am.
I hope clear to everyone.
Yes, ma'am. Yes.
Okay. So now what I'm expecting, that I think I have given you one more variable in the sheet, right? I hope you can see there is weight and there is IQ score. So I'm expecting now from you people that please apply at least on one of the variable, the one sample t-test, and try to interpret it results, right? Suppose I'll just a minute, I'll give you this. Yeah, IQ score is given. So suppose you can assume that the mean population mean IQ is 100. So suppose you need to check whether this IQ or whether this group, whatever group of people these are, they are belonging to the same population or not.
Ma'am, I applied it on 105 by taking the average as 105.
Fine.
And where I get the value at 5.243, that means I'll accept the null hypothesis. The values are same, I guess.
You got the, I'm not getting, you got what? Value of what? T or P?
I got the value of T as 5.243, right, which is greater than the significance value. So I'll accept the null hypothesis.
I think you're not getting the point. Can you share your screen? It is possible for you to share?
Yes, ma'am, I can try.
Yes.
I guess is it visible?
I think maybe it will take. Yeah, it is showing now.
Yeah.
Just a minute. I think it is not that much clearly visible to me.
Okay.
See, just a minute. Yeah, value in it is 5.243 is your T value. Fine. The P value is coming as okay. I think, sir, I think Ali sir, I don't know the name. Sir was asking about the one-sided and two-sided. So in that case, you can see, I think you people are having the latest version of the SPSS, and in the previous version, whatever I am having, there is a problem. But in your versions, you can find that the results are coming in both the cases. Means it's coming in both the form, one tail in the two tail form, right? So there, ma'am, you can see there is a significance section, and there you can find for the one-sided P, the P value is less than 0.001, and for the two-sided P also you can find that it is less than 0.001. I hope it is visible.
Yes, ma'am.
So that means what conclusion you will draw here? You will draw here that the p-value is less than, because we are assuming the level of significance is what? It is point.
It is 0.005.
In our case, it is 0.05. 0.05. That is 5%. But it is showing that the p-value is even more smaller. It is less than 0.001. That is 0.1%. So that means you are going to reject your null hypothesis.
Reject the null hypothesis. Okay.
Fine.
Okay. I look for T value.
Yeah. So I think you are getting now.
Yes, ma'am. Thank you. Can I stop sharing the screen now?
Yes, of course.
Thank you.
So I hope it is clear, everyone.
Yes, ma'am.
What about the remaining? Anyone who has performed this? Apart from the... Ma'am, I forgot the name. Sorry.
Bhavna.
Bhavna, ma'am. Sorry. Yes, anyone else who has performed it? No one except the Bhavna ma'am. Pragya ma'am, you did? I think I can see the thumbs up you have given. Bhavna ma'am, you did?
Understood
Yes,
the
ma'am.
concept, but SPSS software is not running properly. That's why I didn't.
What is the issue, ma'am?
It is showing that SPSS is unavailable since 2 days. I am not able to perform any function.
Have you downloaded it previously?
Yes, ma'am. I was
On,
working on that.
at what date you downloaded it, ma'am?
But I don't know what issue.
Okay, at what date you downloaded it?
Then, since 1 month I was using that.
So I think that is the reason. Reason is very simple, because for when we talk about SPSS trial version, it is available only for the 30 days, ma'am.
Okay.
Fine.
Yes, ma'am.
Okay. What about the remaining? And I think except Bhavna ma'am, anyone else who is having the SPSS, will you please tell me? Only Bhavna ma'am is performing along with me. No one else? After the classes, if you are performing? Anyone? Fine.
I'm also performing, ma'am, but right now my laptop is switched off, so I can't show. So I'm regularly performing with you, ma'am.
Mhm.
I'm
Ma'am.
having a SPSS 16 version.
Okay. Yes,
Ma'am,
ma'am.
I have downloaded, but because I'm traveling right now, so I am just able to listen to your commands and presentation, ma'am, because I'm logged in with the mobile. I'll use it, ma'am. I'll pakka do practice.
Okay, Ketki ma'am. Fine. Okay. So I think if I will summarize today's session, I'll say this thing. Whenever we are talking about the t-test is meant for finding the significant mean difference. Although I think tomorrow I'll discuss the remaining 2 types of t-tests. There we will see the variety. Today we have seen only the one sample t-test where we are having only a single sample. So in that case, you need to compare its mean from the population. And I think I told you this is a parametric test. So there are certain assumptions also. And assumptions are mainly for the normality and the outliers, because we are having the one sample. In case of 2 samples, that is we are discussing tomorrow. So the assumption will be little more, right? So that way, today we have seen that how to check the assumptions, how to formulate the hypothesis, how to perform the one sample t-test, and then we have seen how to interpret the output. So I think what is my expectation from all of you, that please understand the importance of that the p-value and or that's t-value, right? You need to know what p-value says. If p-value is this and if you have set your level of significance this, so what conclusion you can draw using that? Because ultimately, because softwares will give you only the output, they will not suggest any kind of interpretations and all, right? So being a researcher, this is our responsibility to understand what the results we are getting and what the assumptions or what the type of interpretation we can draw from the output which we have got through the software, right? So that is very important. It's to try to understand the importance of these things and try to practice as much as you can, right? If you are having software downloaded, so you can make your own data, and that way you can means suppose you can see I have given you the three columns. One I have performed, second one I think one or two of you have performed, and there is one more column, weight column. So you can assume your weight value. So probably you can assume that the students are belonging to the 10th class, probably. So between the 10th class times, if I talk about the students who are in the 10th class or maybe in the 12th class, so what will be their weight? So there is a standard weight available. Using that, you can find that if the student is 18-year-old or something like that. So in that age group, this will be approximately weight, average weight of the students, right? So that way, that type of things you can assume looking at if whatever the variable you are dealing with. Firstly, that should be the continuous or the numeric variable, and that way you can see for ascertaining its population mean, what things you can consider. So if you are having certain reports and all, so like if we talk about, so there are certain standard values are available. If I talk about if the student is or the person is belonging to the age group of 16 to 18, so this will be the weight of the person or something like that, or average weight of the person, like that. So that way, whatever variable you are dealing, accordingly you need to find a suitable resource, and that way you can ascertain its population mean value. If not, using your own expertise, using your own experience also, you can ascertain that, right? So that is very important to understand. I hope you are understanding what I said.
Yes, ma'am.
Right. So I think this is all from my side for the day. Now the platform is open for the question and answers. If you are having any question regarding what I discussed, please ask.
Madam, here I have a question. Generally, t-test will be applied when the sample size is less than 30. But in just now, we have seen our example in 40 as a sample. Is it correct, madam? I don't understand.
I think I already told you, sir, this thing. Usually when we talk about the concept, I think there are two things you need to ascertain. One thing is the sample size, and second thing is the population standard deviation is known or not. I think this I already mentioned during the slides. I said if you are not knowing the population standard deviation, so in that case you cannot go for the Z, because in case of Z test it is mandatory. You need to know the population standard deviation. But if the population size is very large and you are unable to calculate the standard deviation of the population, in that case, generally we are switching from the Z test to the T test, because in T test it is a case that if the standard deviation is not known, generally that way we are using the T test, right? Sample size is one concern, but usually when we can say this thing, because concern is why, because it is related to the normality. For the small sample, if you will calculate the normality, in that case there is a problem, right? The variable will not be normally distributed, right? But if I talk about when the sample size is sufficiently large, maybe 100, 200, 500, depending upon the size of the population, so that way you can ascertain or comment this thing that the variable or the data is normally distributed. So generally normality assumption, that way we are not considering if the sample size is greater than, but standard deviation is the important criteria to decide upon the identity. Is it clear, sir?
Yes, madam.
Yes, ma'am.
T-test will be applied for dependent variables, I think so. Here we have
Sorry?
seen
Come again,
t-test
sir?
is is the t-test will be applied for a dependent variable or independent variable, madam?
Sir, continuous variable is generally treated as a dependent variable. And here we are having only a single variable, so I think there is no much concept about the dependent and independent, right? But once we will talk about the two-tailed test from tomorrow, so in that case, that type of consideration or that type of decision comes.
Okay. Thank you, madam.
Yeah. Thank you so much, sir.
Chanchal ma'am.
Yes.
Ma'am, your audit went well.
Yes.
You said.
It went well, but results has not been disclosed yet. So we are waiting for the results. So for the best.
Okay. All the best, ma'am.
Thank you so much, ma'am. Yes. Anything else? Okay. No other questions?
No, ma'am. Thank you.
Thank you so much, everyone. So if you, yeah. Sorry.
I said no question. And thank you for this informative session.
Thank you so much, Pragya ma'am. I think I must say thanks to all of you because you people are very, what I can say, interactive, and also you people are listening and asking questions. So I think that is more important. Thank you so much,
Ma'am,
everyone.
tomorrow session at what time it will be there?
It will be on the same time, 5:30. It is fine.
5:30. Oh, okay, ma'am.
Yeah. Because audit is now it's over. So I am available now.
Yes, ma'am. And then on Monday again it will be there, no? Monday and Tuesday.
Same time.
Okay, ma'am.
I think Monday is the last day, but probably Saturday we have not kept the session. But I think Monday we have delayed the session because of my engagement in these works. So if you will tell, we will keep a session on Sunday according to your convenient time.
Ma'am, nahi Sunday mat rakho na, ma'am.
So in that case, it will extend it to Tuesday also.
Yeah, ma'am. Let everyone decide, but it is my opinion.
I think you can decide in group. One of you
Yes,
please
ma'am.
take the lead. Keep there what I can say poll. Whether there should be a session on Sunday or not, something like that, yes and no type. So that we can decide.
Yes, ma'am. Or maybe on Sunday, if everybody is okay, by 11 o'clock in the morning, not in the evening.
I do not have any problem. I am available. So that you people decide. So that way you decide and tell us and to the RFI team, that is Yogaraj sir. So accordingly we will plan it.
Okay, ma'am. Okay.
Fine.
So I request everybody, please let us a message in the group on Sunday what time is okay for everybody, or if it is okay or not. Wo bhi.
Fine. Thank you so much, Ketki ma'am, for taking initiative. So I think it was, yeah. So I think it is the end of the session now. We are meeting tomorrow for the next session. And then by tomorrow, you please discuss this thing so that we can decide the time of the Sunday, right? Tomorrow is Saturday.
Yes, ma'am.
So tomorrow will be the same time. 5:30 I'm available now. No, 5:30 I'm available. Yes. Yes. Anything else? Fine. So no questions. We can wind up the session for the day. Meeting next on, I think tomorrow only, right? We are meeting at 5:30 tomorrow for the next session, and then we will decide upon the Saturday timing, right? So Yogaraj sir, I think these people will decide and will tell us what time we need to keep on the Sunday. Okay, sir. Thank you so much, sir. Thank you, everyone. Good night.
Thank you.
Take care.
Good night.